Hello everyone. We'll just wait for a few minutes and then start. In the meantime, if you guys have any questions, you can ask me. Okay, I guess we can start. I'll just recap whatever we discussed last time. So, starting with references, okay, an important concept other than pointers where you have uh, a variable of certain data type, okay, storing addresses to pointing to some memory, right? So that is the idea behind pointers, where starting from that address, you try to index each region of the code. Fine. Now, in sort of equivalent of that, like while you're trying to modify some data structure, so you might have heard of passing pointers, right? And then passing by reference. So that's the second one. So what we saw last time, passing by reference essentially means you are passing the same object or data structure, okay? And for all intents and purposes for the code, they are the whatever you pass. So for example, here we create A and C and pass let's say A here to set A and set C. Okay. So for this function of like for both the functions, we have the variable name as B. Okay. But for the sake for uh, this call, line 27, this function does, yeah, it does reference whatever input parameters B, right? And does all the arithmetic with it. But for this function, we might as well be calling A for all the operations. And for this line 28 function call set with input as C, we might as well be calling C on everything. So to actually work with the data structure that we want, we are passing, like actually make changes to that. Okay. Not so that it passing the function does not just create a copy of it. And so essentially after the function ends, we want the data to retain, okay, whatever changes we have done. So in those cases, we either pass by pointer or pass by reference. In the case of reference, essentially you can think of it like here B is definitely the name given to the standard vector in the scope of set function. Okay. But the same function works for whatever vector you pass, A or C or D or so on and so forth. Okay. That's the idea. Okay. So if you try to print the addresses and a memory location, everything for B, it will point to the same location of A. So for this function. And for C, it will point to the same C. The usefulness again is that I can write the code once and passing by reference will act the same for every vector that is passed. Okay. Right. So we also saw about return by value. So let's say I want to uh, set some values, but I'm passing the size. So what I can do is, let's say I just create some vector. Okay. But let's say I do not create it inside, outside the call function. I can create it inside and return the whole vector. That also I can do. So in this case, the data type itself will be standard vector integer. Okay. So in that case, you have to, instead of calling, like declaring the vector with some sizes here, you pass the size. So let's say something like, yeah, actually that's already done. So you pass the size, let's say it's 10 here. So you set 10, pass the size itself, and equal to set the data type of the vector and the name of the object. So A is the object that we created here. We can do this also, like do very similar thing. A, right, equals to this. So what this piece of code does is it sets the return of the set function to this vector. What is this return? The return type itself is standard vector integer. Okay. Now the 10, what we are passing is the size. Okay. So that's the size here. Fine. Um, something similar you can also do yeah. So here to see what this actually does, uh, what I'm doing is I'm creating a standard vector of B. Okay, standard vector B of taking the input as that B itself takes input as whatever we pass. Okay, and then it just returns B. Fine. What this enables you to do is create a temporary vector and return that itself. Sort of the idea. Okay, so then you get a copy here. Fine. Obviously, B will get destroyed, but at least you have a copy. You can set the values. I don't think it will copy all the values. That you might have to do it separately. Yeah, but there's also something you can do. Okay. The other thing we saw is just passing by B. Okay. Uh, unless you really want to do this, but it's a mistake if you want to actually change the vector that you're passing. So then what happens is when you call set A, but this thing is enabled, not this one, and this one is enabled. So then what happens is B gets created. Here, B standard integer B is just a data structure, so like just a declaration. No memory has been allocated, nothing. Okay. And seeing from this piece of the code. But when you actually call set A, it inputs A to this function. And what happens is for the set function, function set, the set function named set, B is the only thing it sees, right? Because it's the parameter for it. So what happens here is a copy happens from A to B. Okay. So for the context or for the scope of set, you have the variable B for which the memory is allocated is whatever the size of A. Okay. It's called a copy constructor. We saw constructors last class, but you can think that here, since B is an object, okay, of the class standard vector template class, we'll talk about templates later, but it's a data type is like it's part of the class standard vector. Okay. So for that, when any new object gets created, the constructor gets called. Okay. Be it the default constructor or some specialized constructor. Okay. In this case, this is what it's called a what is called a copy constructor, where in which case it takes the sizes, like takes the size of A and allocates that much memory for B. Okay. But the thing is, when you try to make any changes to B, the scope for this B is only till the function. So whatever changes you make will eventually get destroyed. So in effect, you do not change A actually in this case. Okay. So this is called pass by value. It shall, you can also think like it shallow copies A to B. Okay. This is what we saw last class also, like last session, printing all the values and everything. Okay. Excuse me. Now, if you pass by reference, in effect, what you're doing is you're actually passing A itself. Okay. Here, there is no copy constructor, nothing gets called. It's a reference. So the code understands that you're effectively passing A itself. Okay. Which is like a lot of situations you want to, at least let's say in this case, we want it. This is the, this is what we want from the code to do. Okay. So then we write the loop. We go over the sizes, we write all the stuff, and then that's it. We can end the loop here because writing to B is effectively writing to A. Okay. Similarly, calling C, writing to C is writing to B, sorry, is effectively writing to C. Okay. And then you can print stuff and so on and so forth. That's fine. Okay. And yeah, after the set function, we also saw about the print function just written separately so that it takes a vector and then just prints it. Okay. This one we should definitely pass by reference because otherwise, if shallow copy happens, you'll just be printing zeros. Okay. Right. Zeros because the default value that is set when the standard vector constructor gets called, let's say for integer and so on and so forth. Default, it is the behavior in, I'm not sure in every compiler, but at least most modern compilers, most of them just set it as 0. Yeah, at least GCC does. So again, that is something one should not take for granted. Again, a source of error. So usually while passing the size, you pass the default value also, whatever you wanted to set. Okay. You can set it 1, 0, or any other value 1. So actually a good practice. Just pass the value, actual value you want to set. Okay, right. Another thing about performance perspective is that when let's say a copy happens, or yeah, like this sort of code happens, because you're creating another B, okay, and not passing by reference, because a B gets created, its memory gets allocated. That is expensive, and normally try to avoid creating or allocating memory multiple times. Okay, it's better to allocate memory once, okay, maybe a big chunk of memory, and then try to reuse data from it so as to retain performance. Okay, right. This is another way of calling the constructor for A. Okay, so usually if you just pass one value, the others are default values. So 0 is like one of them. The second one is like, if you first is size, the second is this actual value that you're passing. Okay, so you've actually passed a specific value that you want all of your um, vectors values, like all the index to contain, right? So you pass that same value for all of them. And then later on you can manually change it to whatever you want. So that is again always an option. Yeah. Right. So next is we also saw about inline, right? So we can define macros. So let's say there is an add macro which takes input x and y and just returns x plus y. I wouldn't even say it returns, it basically replaces the text. Okay. So avoid macros in general, as in it's definitely useful, but if you can avoid, and so this is basically like in this example, inline function will do the same job. Okay, and it's at least clean in the sense it gives the intent of the programmer, whatever they wanted to do, right? So in that case, uh, at least given the use cases, you can switch to inlines, and we saw some previous examples also. Um, so we'll also be seeing constant expressions and other stuff, but essentially the idea is that you try to uh, do it at least more syntactically, at least the more modern C++ way, so that it actually reduces errors and bugs later on. Okay. Um, it's not that. Okay. Is there a question? Oh yeah. I mean, if you guys have any questions, you can feel free to ask in between anytime. Okay. Right. Yeah. Continuing. So the idea is that at least with macros, yes, they're useful, but one has to be very careful. And because they're prone to mistakes, there are a lot of alternatives provided in C++, like one of these. So maybe you can give them a try. Okay. Right. In this particular example, the reason to use this add macro was that it takes x and y and replaces it with x plus y. Usefulness is that it doesn't care about the data type of x and y. And if they support the plus operator operation, okay, this code will not throw an error when during compilation, as in after the macro is done with its job. So, okay, another thing about macros, they are preprocessors. So before even the processing or compilation of your code happens, macros take precedence. They get evaluated. After their job is done, then the compilation happens. Okay. So in this example, we have the fine, main function. We have defined A and B. Cool. Then we set C equals to add AB, or we can write it this way. In this particular example, let's go with the macro one first. So it takes input as A and B. So it will take 676. Okay. Take 76, replaces with 6 plus 7 plus 6. Okay. And that text itself gets written here. So essentially, this whole line looks like something like this. My bad. Sorry. Yeah. So this is what it looks like in after preprocessor is done. When compiler sees this, it knows 6, it knows 7. It will just evaluate it during compilation time. Okay. Because these values are known. Let's say these values are not known and come from some other function. It will also similarly do that, do the same thing. May not be at compilation time, but at least in runtime, it will basically write it as, if let's say A and B are coming from some function, and like let's say it's not the main function, but maybe some other function call, right? And A and B are not known at compilation time. So it will look like something like this. Okay. For this add A and B. Okay. So compiler when it sees this code, it will try to compile A and B, like this C equal to A and A plus B. Because A and B are integers, so this operation is sort of well defined, and then putting the values in the output value in C. Okay. Just so we are on the same page, we are all on the same page. I hope this is clear how the macro actually works. Okay. Very similar, but without the macro thing. This add function returns x plus y, takes integers x and y, and returns x plus y, right? So to get this x plus y, like this simple code inserted here, just like a macro, we add the inline function. So that let's say you want to call this add function a lot of times. So to avoid the function call overhead, you put it as an inline function. Okay. What that does is this inline function then has this body, right? It's a small piece of code. It just inserts that. Yeah. Very similar to a macro. Okay. Sort of the idea that you get the performance of using a macro, but now using some modern features of C++. Okay. Any questions? All right. So moving on. This was the line. Okay. Moving on to the class. Started with defining class. What is a class? How do we define objects and so on and so forth. This is part of something called object-oriented programming, where you define a template, a sort of blueprint. I wouldn't say template because C++ has its own template, but the idea, I hope you get the idea. You sort of define a blueprint for the class, how your objects should look like. When you try to instantiate any object, what I mean by that is you create sort of examples of that object. So for example, for example, let's say I have complex class, okay, defined this way. Then what happens is I can try to represent any complex number using this class. That's sort of the idea. Okay. Assuming I want to define all again, a complex number will have real and imaginary parts, right? That's the first thing any complex number has. So imagine that I want to represent them using double. So more precision I'll have. Okay. Let's just assume that. Okay. Within whatever precision I can represent, I'll try to represent all complex numbers using this uh, format. Okay, this blueprint. And the nice thing about classes is that you can have member variables. So these are called member variables. Okay, and you can also have member functions. Okay, or also it's also called method of the class. Okay, I think that's more common in Python maybe, but anyway, same idea. At least this is something part of the class which allows you to call this function from the object itself. So one can say, why do we need this, or maybe something like that. The nice thing is, because this function is inside the class itself, it has access to the member variables. Okay. Remember, member functions always have access to the uh, member variables. There, it really doesn't matter what is the uh, partition, as in not partition, it's the it doesn't matter if your variables or functions are defined as public, private, or protected. Okay. The functions inside the class will always have access to all the ones you define inside the class. All right. So the nice thing here is that I can define something called a norm. Okay. Sort of like the L2 here we mean when I say norm, I mean the Euclidean distance or the L2 norm of the complex number, which is essentially the distance of that complex number from the origin. Okay. That's something you can calculate this way. So real square plus imaginary square, right? Remember the real and imaginary the scalars themselves are real numbers. Okay, so one can do this. It's just a representation of the complex number. No need to worry about I here yet. One can extend the same thing, okay, by overloading operators, like adding operator plus, operator minus, operator division slash, operator star. So what that enable you is enable to do is you can add, subtract, divide, and multiply complex numbers. Okay, so on and so forth. Right. Next is yeah. So something like this. So to instantiate or like to use this complex class inside the main function, you just use the name of the class like a data type. It's the another way of thinking of about classes is that they are sort of a custom or a user-defined data type. Okay. So the whole blueprint looks like something like this. So, and C is the name of the object that I gave. Okay. So complex name itself is acts as a user-defined data type. Okay. To so we define it, and to set the values real and imaginary, you can also do it this way. So currently, as we saw constructors before, here I did not define a constructor explicitly. Okay. Uh, so here there's something called a default constructor that gets called, okay, which takes care of setting your real and imaginary to these values. Okay. Then you can just try printing real and imaginary and norm, right? So to do those, you have to use the dot operation. So for this instance of complex, right? So the variable named C, to access its real part, you have to use dot real. Okay. To access its imaginary, you have to use dot imaginary. To access the function, you have to use dot norm and then give brackets. So giving of the like these brackets uh, means you're calling a function. Okay, this is sort of the syntax in C++. So when we call something with brackets like this, even if they don't take parameters, this is like a function call, right? When functions themselves while defining also are done this way. Okay, right? Similarly, I can define complex C1 and C2. So two more complex numbers and then print their norms and real values and imaginary values. Okay, right? Any questions so far? Right. Uh, Building on top of that, so we define the complex number, right? Building on top of that, we can also define something called a line class. Sorry, line class. The usefulness now, because every complex number is a like a two coordinate point, right? I can join two such complex numbers, and create a line, more specifically a line segment, right? But yeah, I hope you get the idea. So define this sort of template or sorry, this sort of blueprint, okay? I can define this in C++, okay, in a class again. So I'll define a class or line, and that will have A and B, right? So what that does is it has two member variables, A and B, okay? But this time they're not uh, just inbuilt data types like double or something. They are of the user defined data type, like the complex class itself. Okay. With that, then one can define something called length, right? So because A is a point and B is a point, one can calculate the distance between those two, which will basically be the x coordinate difference square plus y coordinate difference square. So sort of the idea. So the x coordinate will be the real parts. So that's uh, that square is what we do here. And then the difference of the imaginary part. So that's the y coordinate. Okay. And that's square. And it's square. Yeah. So we define complex numbers P1, P2. Okay. And use those P1, P2 to construct S0. Okay. And then it's printed. That's as simple. Printing, we can print the length, so that's what it gives us. Fine. Then we went a little ahead and defined a square, a unit square, okay, on the coordinate axis. So its two line segments lie on the coordinate axis, okay, and it forms a square. So to define those line segments, we use the line class, okay, and define the complex numbers this way. So we pass the complex numbers this way and define lines L1, L2, L3, L4. Okay. So starting from 0, 0, okay. So the first one is 1, 0, 1, 1, comma 0. So this is on the x-axis from the origin on the x-axis to the point 1. Okay. Then from that point on the x-axis 1, 0, we go to 1, 1. Okay. Then from 1, 1, we go to 0, comma 1, which is okay. So from here to here, this is sort of like in uh, right or the east direction you go. Okay. And from here to here is like north, right? And in this third case, the line L3, you go from 1, 1 to 0, 1. This will be going towards west. Okay. And from 0, 1 to 0, 0, it goes south. All right. And then we can just print all the lengths. Okay. So this is sort of an example. You can create more polygons and polyhedra or even 3D surfaces and everything, and represent them in C++ using classes itself. Okay. Now, again, you can extend the same thing. So a point can be defined for something called a norm can be defined for points. Something called a length can be defined for lines and so on and so forth. So you can keep adding all these useful functionalities, and correspondingly each of the usefulness is that each object will call its own length or own member variable. So there is no confusion about keeping track of data and everything. Okay. You can write repurposable code. Okay. You can reuse them multiple times by using just a blueprint. Okay. Yeah. Next we saw about is classes, right? Sorry, the constructor piece of the class. So we define something called public. Okay. So what it means is whenever you call anything which is public, then so whenever you call anything which is under public, okay, from outside the class, it is allowed. Okay. And when you try to call any member function or variable which is under private, that is not allowed. Only the member uh, functions, as a norm or get real or set real, only they can call the member variables which are private. Okay. It's a useful distinction. Others cannot call it. All right. Now we come to the constructor part. Okay. So here in this case, what we're doing is we are enabling our constructor to take some parameters. Okay. These are default parameters, as in we write equal to 0, equal to 0. So as in, if you do not pass anything to the constructor while instantiating the class, okay, for example, this way, we can either pass some values or we do not pass anything. So we don't pass anything, it will assume them to be 0 or the origin. Okay. That comes, so to look for which is the constructor, that the way to understand is the name of the class is used sort of like a function. That is a constructor. Okay. It has the brackets, right? It takes parameters if you want to pass or you do not. That's up to you. Like here in this case. Okay. The second part is you have this colon, which enables you to set some member variables, okay, during instantiation of the class. So I understand sometimes you might think like, why do we need to worry about uh, setting it this way? Why can't I just put it in the body? True, but remember, let's say your uh, double, real or imaginary. Normally, yes, these are, it's like your point is an instance of object of this class should be able to, let's say, change values. In general, you may want it, but let's say sometimes you do not. So let's say this is cost. Okay. So then what happens is your real and imaginary values cannot be changed, right? So you cannot write something like real equals to some value. So then how does one even set these things, right? So during the instantiation of the object of the class, okay, so let's say text underscore real and underscore imaginary, you can do this. This is a valid code. It will take underscore real, underscore imaginary, and set real and imaginary to it. Okay. Now, for the whole lifetime of that object, whatever this complex number you called for, with, right? For the whole of its lifetime, the real and the imaginary part won't change because they're constant. Okay. I hope you get the difference. So having this piece of code works even for these cases where you were not able to, uh, like you won't be able to set it manually because they're constant. They can't change values, right? But while instantiating the object of the class, okay, so basically for the lifetime of that particular object, whatever values you pass, okay, you have to here, I think it doesn't matter if you pass as const or not, but yeah, maybe you have to do. But anyway, the point is you can set the member variables just during the construction itself and ensure that it never changes because now it is const qualified. Okay. To understand when the constructor gets called, okay, so in the body, I just put standard C out with constructor gets called, okay, for complex class. And this text will get printed depending on when the constructor gets called. Okay. On similarly, we also wrote the destructor. Okay. So which with the body that destructor gets called for complex class. Fine. Also, we have some public inside the public a norm function. So whatever we had before to use for this complex number. And we also saw uh, some getter and setter functions. Okay, maybe I'll come to that. So let's see some the code at least. So this way, uh, note, use the small brackets here, okay, passing the values. So which basically means I'm calling not some default constructor, but this constructor, the one that I specifically defined. Okay. So anything, yeah. So that one sets underscore real and underscore imaginary to whatever I pass. And when the constructor gets called, it sets the internal member variables real and imaginary also to that. Now, because these are private members, I cannot call them directly, but I can call norm, okay, later on, which calculates the square root of this internal member variables and just returns me the answer. So indirectly, I can get useful functions like this and which operate on the member variables itself, but the member variables themselves are not exposed to the user. Okay. So to keep this sort of uh, demarcation, okay, to hide sensitive, let's say, data from the user, one can make things private so that it keeps, well, definitely your class clean and it segregates the permission allowed, right? Yeah. Just a second. Okay, sorry for that. So continuing, we also see here two examples, how to call constructors and which one gets called. Okay, so if you run this code, so let's do that. C++ constructor, yes. Yeah. Yeah. So let's say I do not have this and oh, okay. Yeah. So let's say I have this and then run it. Yeah, it doesn't allow because I don't have an instantiation of the class. So to do that, one can do it this way, which takes care of both of them. And because this specific constructor gets called, we see the uh, output constructor gets called for class, printed twice. The norm also gets printed. Okay. So first one, that is because we pass some values. But for the second one, because the default values are used, so which is 0 and 0, we get the 0. Right. And when the scope of main gets done, C1 and C2 go out of scope, right? That's when the destructor gets called. Okay. So that's a very useful thing about classes in C++. The uh, constructor gets called whenever the class is instantiated. Okay. When an object gets instantiated of a class, of a given class, whenever that object goes out of scope, the destructor gets called. Okay. Cleans up memory and everything. This idea, I hope you try to at least understand, because this is a very powerful idea, which will lead us to smart pointers at the later part of the course. Okay. All right. So, any questions so far? Okay. We'll also see about some final thing, the getter and setter functions. So, because these variables are uh, private, sometimes, and let's say you have a lot of these variables, sometimes you want to give access, but maybe just print access, not as in just give the value, whatever is currently there, but one should not want the, let's say this is an external library, and so the developer should not have access to change these values later. Okay. Or maybe you passed it to some other function in some other file or class, right? And do not want that function to change the internal variables. So in that case, you can just do something like get real and return only the value, so that this is just const. Here it's change value, but you can just return a const value. Okay. You can return it like a not double, but a const double data type. That's also something you can play around with. You can also have a setter function which explicitly sets that function. So sets the value, changes the value. Okay. You can also do that. So these are called getter and setter functions. Okay. All right. Yeah. So yeah, okay, moving on. We'll look at more examples. So yeah, this is I think fine. We'll look at something called static variables, but in the context of a class. Okay. Usually, static member variables, they are like um, let's say this is declared. So let's say a variable is called static. It has a certain value. Okay. And in the in the scope for other places also, it is the same thing. I'll maybe give an example and try to explain. Let's say I define something called sorry about that. So something called my class. This is the name of my class. Okay. So I have something, a memory variable, okay, called index. By default, if I don't use public or private, remember it means it is private. Okay. So then next, I'll define public portions. So something like void get get a function. Okay. It doesn't need to do much. It just returns that returns the value of x. Okay. Sorry, I can't make it void. So this is int. Uh, Maybe I'll just do it this way. This is since I have iOS stream, right? Instead of return, I can just print it. Or I can do it in a different way. I just call it function, okay? But this time, this won't be return, okay? What this will do is, it will set x to 15. Okay. Next, oh, yeah. So another public function void called print, okay? X as x plus 5. Okay. And next, so remember, notice I just when I call this function, it just does not print something. It also changes the value. Okay. So we'll look at this example and try to decipher how static plays a role. Like how does it work, right? This will become the blueprint for us. Next, we'll go with main. Okay. We'll define my class. Maybe call it A. Okay. I'll define another one, which is B. Okay. Then A dot func. Okay. Doesn't take any input. Fine. Then NP function. Also do the same thing with B. Okay. With A, sorry, I'll print the call the print function, which is this one. Okay. And with B, also do the same. Okay. Right. So let's try to understand what this code will do. Okay. Can anybody tell me the outputs for all of them? I'll give some time. Try to figure it out. So far, it's sort of straightforward. We have defined classes A and B. Okay. Of the name of the class is my class. Okay, just some temporary class that I've defined. I defined two functions which are public, so they are able to call from outside. Okay, outside the class. So like something like this. Func sets x to 15 and print sets like it adds and then prints it. Okay, and x is the return member variable. Right. So it will print 2020. Okay, good. Right. Okay, good. Let's compile this and see. Right, let's check the output. Okay, that's correct. So I hope the idea is clear. So you have function which sets x to 15. Fine. But that for what? So that x is part of A. Okay. Similarly, and then moving on, 15 is set for x. Fine. Then when you call print, it's increments by 5. So that is 20. So then when you try to print x, it prints 20. Okay. Second part, the function func sets
x to 15, but for b. Okay, remember the memory of x for a is different than memory of x for b because they're two different instances of the same class. Okay. Uh, Normally they do not share any memory. Okay. So that's why when you call b.func, you get set x as 15, but for that but for the x which belongs to b. Similarly for b.print, it increments to 20 and then prints x. Okay. All right. I hope this part is clear. Now what we'll do is set this x as a static variable. Maybe I'll comment. Okay. And then I have to add another line. My class. Okay. Then the name of the variable as 0. Now can anybody tell me what will be the outputs? Okay. So I'll explain what a static variable is. So essentially, when I make this integer as static, okay, this memory is actually shared by all instances of the class. Okay. Normally that does not happen. Okay. But you can make member variables as static so that that memory is shared by all instances of the class. This is a useful way where, uh, again, it depends on use cases, but it's a very useful way to actually have members of data as a member of a class and actually being shared by all the objects. Okay. All right. Okay. So because I've given you a hint, okay. So 20 and 20. All right. That's a attempt. Okay. That's a good attempt. But remember, X is shared. Right. Right. Correct. Correct. So yeah, let's try to print this step again. You see that? Yes, that's correct. That's 20 again. For now, like you said, we'll remove this second function and maybe go back to the previous code. Just remove this one. So it prints 20. Oh my God. Okay, it prints some very large number, garbage, something. The reason for that is while a.func set the x value to 15 in the first case for a, we did not do any such thing for b. Okay. And when you have some variable and not set it to anything, it just has it reads off, like for this case, we added 5. That's fine. But when you try to print it, it gave us some garbage which is already present. Okay, we not set it to anything. So there was some number which is already present. So that's what we got here. Okay. But this at least tells ensures at least tells the idea that we did not set anything to 15 like for B. So hence we got this garbage. But what if it was static? What happens in that case? So this is a syntax for static. You um have to instantiate it. Okay. So because uh member variables get instantiated when the class gets instantiated, right? But for static members, you have to instantiate them separately. Okay. Okay. X is 20. But there are two print statements. Yeah, correct. So if we print them now, exactly. So you get 20 and 25. Reason being, again, for the audience. So a.func sets x to 15. Yes. Print function increments it by 20. And so when we print the first time x, so this line will print x as 20. But when you print b as b.print, okay, only this function gets called and x gets incremented by 5. Till then, everything is same. But because X is a share, it's not shared exactly, it's like static member, right? So yeah, you can think of it like shared across objects. So the previous value of X, which is 20, is used here. Okay. That increments X to 25. Okay. And hence that gets printed. You can have another object, okay, and call C, all right, that will increment it again, so on and so forth. I hope the idea is clear. In one case, in this case, the variable, okay, it is not shared, okay. Each member object has its own instance or own memory for its own X, all right. But when it's static, they all share it. Okay. These are the syntax you have to be careful of. So to declare, to access static member, so you have to use the name of the class as the namespace. Okay, give double colons, and then access the member variable. Okay, and actually instantiate the value for it. Okay, all right. The reason for this is that static members do not occupy any memory when actual object gets created. In the sense, uh, others get their own memory. So for example, this one, even the uh, functions name, right? They also get the memory and everything. But static members themselves do not get, because uh, by design, it is such that who will allocate the memory, right? So we do it separately outside, and then all the member uh, functions can just focus on rest of the code. Okay. Yeah, there's a question. For static, only one copy of the data object stays in memory till the program exits and shared by all classes that use it. Right? Yeah, that's correct. Yes. Only one instance of that one copy in a way, or you can think like only this X exists for the whole program. Yeah, at least for the whole for all the objects that we create from this class. You can have a local variable X also. Yeah, in some scope like this. You can create a scope and have local variable X. You can access this X by using my class this one, but here it won't be allowed because it's a private member variable. Uh, if it was public, then you could access X, something like that, so, in some way like this. Okay. So, any other questions? Okay. Right. Moving on. So let's take another example for the static. Okay. This time, apart from including IOStream, I'll also include the string header file. We'll be working with some strings now. So I'll have a class called data. Okay. So inside this, a member variable I'll create, which will be a string. Okay. Let's call it ID. Okay. Next, this is of what scope, as in, is it public? Is it private? Is it protected? I don't mention anything. I give the hint already. So I'll create the constructor, const standard string. Okay. So text a reference. Call it ID underscore, okay, which sets the internal member variable ID, okay, using the ID underscore. Then counts. Okay. So basically says construct. All right. So this is part of the constructor's body. Okay. Where I say what happens when the like basically this body gets called basically this body, whereas in there's a print statement that gets called when the constructor gets called. Okay. I can then print the ID, okay, and then end the line. Okay. Similarly, we'll write the destructor because why not? No need to pass anything. Just have the I require the body itself, so something similar to this. I'll put all right, destruct, right? So this is the sorry. So this is the portion we wrote. So basically a data class where there's member variable ID. We write the constructor and destructor. So then should be they have to be public actually. So only then you can access them outside this class, right? So it takes ID, constructs the sets the ID, and what I'm saying is a constructor gets called, and when destructor gets called, it'll say this string got destroyed. Okay, so that's sort of the idea we're going with. And format. Okay, class again, my class. So this is another class that I'll define, but this time I'll have static objects of the data type D. So D1, similarly D2 and D3. All right. I instantiated some static objects, okay, where the data type is the custom data type that we have here. Okay. Next. So that was the class defined. Okay. Then because these are static, right? So remember, similar to here, when there is a static member, okay, we have to instantiate it separately before calling the main function. We use the data type as the class name as this namespace, okay, and use colon double colon, basically a namespace, access the data type and set it. Okay, we'll do something very similar. Call my class, call D1 and pass because it sorry, because it expects a string. Okay, so it'll pass a string here. So call it first object and then end. Okay, quite similarly, we'll have 2, 3, first, second, third. Okay, and finally we'll have start with main function that should always be there. So, yeah, just end main function. So it's a little different than what we normally have a code, okay, where you normally do not have have things inside main, but here the main function is just empty sec because main has to be there. So we just put it and have the whole code like this. Okay, I'll go through it again. There is some data structure. There is a class date called data. Okay, it has a member variable ID. All right, it has constructors. Okay, a constructor which takes ID by reference, sets ID to that whatever it takes as ID underscore, calls a statement or a print statement when the constructor gets called, calls a destructor when the destructor gets called, it calls this again a similar print statement, okay, for the destruct part. Fine. So that is the a simple class of data. Now we define a my class. Okay. In this my class, we define 3 objects, okay, all of them static, but of the data type data. That is the user defined data type coming from the class itself. Next, we use my class, okay, D1. So we refer D1 object, okay, inside my class, and you have to give a data type for it also. So that is the data. So hence we give the data type data. And to instantiate this object, you have to pass something in the brackets, which is for the constructor. So I use the string itself, first object, okay, for the first one. Similarly, for second and third, we use second and third object. Okay. I hope this is clear. Because D1 is of data type data is used here. This is just a full name of accessing D1. Okay. Because D1, D2, D3 are static objects, okay, to access or to set them, we have to give the full name. As in, we have to use the name of the class as the namespace. Okay. Now, can anybody tell me what will be the output? So if I run this code itself, what do you guys think will happen? Maybe I'll just start with uh, this only two. Sorry, I mean, I'll comment these two. Just start with one. What do you guys think will happen? We'll start with simple and then make it more complicated. Okay. Any attempt? Yes, let's
Construct subject, construct an object.
right. So first object will be called in the ID, the first object will be written. And so it will be construct first object, destruct first object. Yes. Correct. So let's compile and check the output. Yeah, that's correct. So again, the answer also confirms what we were thinking. So I hope the idea is clear. So here the constructor gets called, right? So when the constructor gets called, the ID here underscore is basically the first object string. So that gets passed, right? And ID is set. And when the constructor gets called, in the print statement construct with the ID, which is this part, that's what we get. So that was the constructor part. That's fine. I've always told is whenever your object gets out of scope, then only the destructor gets called. But I don't see an scope here because this is not inside any scope. Then how does the destructor gets called? Usually it is inside some brackets or something in the main function. So yeah, any thoughts? Okay, so what's happening here is the D1 is sort of like in a global scope. Okay, so every C++ program has in the starting a sort of a global scope. The brackets themselves set the scope, yes, but you do not actually need brackets always to have a scope. Okay, so that's what is happening here. For the whole program, there is a scope and it is in the global, that scope is does nothing. Here it does nothing actually. It just ends, right? I actually should have written 0 or something, but it's okay. I'll just make it void for now. Okay. So when the main gets called and it sees that I don't have anything to do, the program ends. Okay. And when the program ends, the global scope ends. That's when the destructor for D1 gets called. Okay. All right. Any comments or any questions? All right. Now let's bring some more statements. Now, what do you guys think will happen? I hope the idea with the global scope is clear. So variables, like you might have seen people declaring int x equals not x, maybe like y equals to 500, let's say. So this variable is in the global scope, as in inside main anything or any later functions can call this variable. Okay, because it's in the global scope. To specifically access this, uh, let's say inside main or here itself or wherever, you use the uh, namespace operator like this and call one. Because global scope do not have a particular name, like you can have a nameless scope, so you can do it this way to call or set or whatever. You can use double colon and then call y. Okay. All right. Oh, nice. That's some good attempts. Yes, I'll comment this. Okay, maybe I'll have this and this also. Maybe just have a C out print statement because why not? Okay. So first object, second object, construct, and then destruct first and then second. Second answer is also the same. Yeah. Oh, but there's a difference. The destructor second object and then destruct first object. Oh, nice. Right. Ah, interesting. So which object gets destroyed first? Right. Okay. So let's just print it and see. I don't think this should be. I'll just comment this not required, and this is the right as well. See that works. So void main has to be integer. I guess that is not allowed. Cool. I guess this compiler doesn't allow. But yeah, anyway, I must return it. Sure. Okay, so the first one was simple. Yeah, actually, this is also a good one. So the constructor first gets called, okay, because before even the main class, because this goes from top to down, right? So it will compile all this program and code. It says class and says, okay, there is a class of a static object and everything. In the global scope, it constructs something. Hence the constructor gets called first. Okay. Then it calls in the main function. Okay. So the main function gets called. It prints y. That's what we see. 500. Okay, good. Return 0. That's fine. Main anyway ends in this part. And then when the whole program ends, the global scope ends. Hence, D1 goes out of scope. So the destructor gets called. Okay. Now we will bring back the second case. Okay. I think we can leave y. I hope we get the idea. It should not change anything. Let's see the answer. Okay. Yes, the second answer is actually correct. Okay. So let's see why. Okay, let's see why. So the first one, the constructor gets called. Okay. And the second one, the constructor gets called. So that's like first and second. That's I think sort of clear why this happened. The y gets called because after this global scope compilation is done, uh, then we get or then we get then the main function gets called. So then the y value gets printed. Okay. Again, the global scope ends. Now the destructor destroys these objects. Okay. First, the D2 gets destroyed. Hence, that gets destroyed first, and then D1. Okay. So it will be hence second object gets destroyed first, and then the first. So the second answer is correct. Good. Yeah. But good attempts. Please always keep thinking. So it's very important that code like this might be a little confusing, and then you might always like obviously you have to get the answer, you have to just write the code and compile and see. But to understand why this happens, it's good to keep thinking about this. Okay. Right. So when the program in compile, the memory addresses of the variables are pushed in stack. Yes, that's correct. And when they go out of scope, they are popped out. So we get that out. Yes, that's absolutely correct. Yes, it's absolutely correct. Yeah. So unless you are um, using some heap memory or something like that, usually these sort of cases are static allocations. Yeah, and that's actually correct. Because of the order in which your stack gets filled, it, it normally is from top to down. Okay, so first this variable gets uh, destroyed. So like that is the popping of the stack. Okay, so because that gets popped first, the D2's destructor gets called first. Okay. Now, just to okay, any question or okay, okay. To confuse you guys even further, okay, let's switch the order of these two. Now, what should be the output? Mind you, I switch the order of D1 and D2. Okay, first object, second object, y is 500. That's I think clear. And then second, and then first. Okay. All right. Any other attempts? Okay, let's okay, it's another attempt. So the first is second gets created, then first object, then destruction is first object and the second. Okay, okay. Let's see. Okay, so the order in which they get created does not change. Okay, because uh, you might declare them in a different order, yes, but remember, static member variables do not have any allocation when they're declared. Okay, and this line is the one which gives some allocation to it, as in the constructor gives the allocation. Very similar to one we have it here. Okay, very similar to one here where we instantiate the variable. Okay, here we're instantiating the variable with the constructor by passing a string, and then in that case the construction happens. Okay, that's it. That's what gets called. So for in this case, even if I interchange, okay, the first object gets uh, destroyed. Sorry, that gets constructed, and then the second. Okay, so the changing of this order doesn't really affect in which the construction happens. Okay, uh, the 500, I guess, is obvious. That should not change anything. The destruction for it, the second object gets destroyed first, and then the first. Okay, why is that? Remember, that's because the instantiation happens here. Here is just a declaration of static members. So normally, yes, if you do not have static, the sort of the default instantiation also happens here itself. Okay. But for static members or static variables like this, the instantiation only happens in the global scope where D1 got instantiated first and then the D2 object. So naturally, D2 gets destroyed first because that goes out of scope and then D1 gets out of scope. Okay. To keep the things same. So I'll keep these two as same and then just interchange these two. In this case, you will get your construction of second as first because second gets called first. First object gets called second. So that's why you get it second. In destruction part, D1 gets out of scope first. So the destruction of first object happens first. And D2 gets destroyed second. So second object. Okay. So what matters is not the order. So we can actually check that here as well. So I'll change both of them. Okay. This thing that we just saw should not change. So second first, second object, first object, second object, first object, first object, second object, first object, second object. So the order in which you actually declare your static members does not matter, as in terms of construction and destruction. Okay. What matters is where you're actually constructing and destroying. In what order? Okay. So the scope here is of the global scope, and the first object to get created prints its own statement, okay, for construction. Then the second object. In this case, the first object is D2, second object is D1. Okay. So hence the statement, second object, construct second object, construct first object. While going out of scope, this is the order they follow. Okay. Class in this case is just a blueprint. All right. There is no, one can in a way say there is no instance of this class, but well, the D2 and D1 in a way are sort of an instance of my class. Okay. Not completely, but in a way. Okay. All right. I hope this is clear. Any questions? To complete this, I'll just add D3. I think you guys can guess what should be the output now. Okay, I'll change this to top. Okay, why not? In this case. Any attempt? Just print this and see. So second, first, third. So that is the order in which the constructors get called. So the order in which we had the original data really doesn't matter. And destruction will be the completely reverse. So third, first, second. That's what we have. Okay. Yep. Any questions? Else I can move on to the next concept. Okay. So we'll see this uh, variable. Okay. Uh, a useful variable present in all classes of C++. Okay. So let's see how to use it. So I'll define my class. Okay. Then let's say it has two variables, X and Y. Okay. We'll also define a function that we'll call. Okay. So these are again private numbers. Call it a void function. Okay. Which takes two inputs, let's say A and B. All right. Which and then yeah, let's say X is set to A, A, uh, A, Y is set to B. That how do I put it? It's the inputs. So there are two inputs. We have internal number of variables. We set them using the function function. That's it. Okay. So far so good. We'll have the main function. Okay. My class object. So this will be the object of the my class. I'll call it obj. Okay. Then let's say I set P as 7, Q as 5. Okay. OBJ is the object. Okay. Now I'll call the function of it and pass P and Q. Okay. Those are the A and B variables which will set X and Y of object. Okay. Um, yeah, that's it, I guess. Okay. As such, this function, I can only compile it. It will not do it. It will not print anything. So just compile plain and something because there's nothing. We're not printing anything so far. It just sets variables and just ends the file. Fine. It's a very simple code. Everything is great. Like fine. Okay. Now look at variable. Okay. Which gives you a functionality to do this by using this. Okay. And it can be a little confusing, but when I mean the THIS here, this, okay. You access a member variable using this pointer, okay, and then set it to A. Sort of the same idea. You can use the same, you can do it this way, or you can do it this way. Okay. The THIS this allows you to do a very similar operation, okay. But remember, the THIS this is basically a pointer to the same object of the class. As in, because it's a blueprint, any object will have its own address, right? And that address is stored inside THIS. This to access members of a object pointer. Okay, maybe I'll show it this way. So let's say I declare object. So this is the instantiation of object, but this time we'll have a pointer obj, which is let's say instantiated. Sorry about that. We can use the new operator we saw before. Okay, basically like a heap allocation is an operator to allocate or instantiate. Okay, use my class pointer object equals to new my object or something. Okay, the point is now here object is of data type my class. Here the object is of what data type? Remember about pointers? So the object itself just is the pointer. It stores what? It's a my class pointer, correct? So it actually just stores size underscore t or long unsigned integers. That's it. Okay. To access anything from whatever the point is pointing to, we have to dereference it. Okay. So to actually dereference an object, okay, and use its member functions and variables. Remember, we used to use, let's say, to access x, we'll use obj.x, right? Assume x and y are not private, but public members also. So we'll use object.x and object.y, right? If object is a pointer, okay, my class pointer, to do the same thing, use the arrow operation. Okay. What arrow operation basically is that it is sort of like a fusion between the dereference operator along with the dot operation. So here star is not multiplication. I'm dereferencing the object, okay, and I'm actually accessing the my class data structure, okay. Then it uses a dot operation to access the member variables or member functions. You can also do something like this: object member member, and then pass let's say pk. So this one looks very similar to this one, okay? But if object is a pointer, not a pure object like this, okay? It's a custom data structure pointer, you use the arrow operation. Okay. Now, this object is what is the pointer, right? This is exactly this THIS. So in this specific example, yeah, arrow gives members of object the pointer is pointing to. Members of the object it is pointing to. Arrow doesn't give members. I mean, it essentially is like a div reference, and then you access the member. Yeah, but sort of the idea. Yeah, yeah. It's kind of like dot. Yes, you access the members using dot for plain objects, but when they are pointers, you have to use the arrow operation. That's sort of the idea, but essentially, arrow is combination of two operations. You dereference and also use the dot operation. Okay, right. So yeah, like what I'm saying is, so in this example, okay, when obj is an my class pointer, okay, it's a pointer. Whatever the pointer is, as in this is like a custom data type pointer, right? Okay, that pointer is readily available for the objects class itself using the THIS keyword. Okay, so essentially every object of any class can access its pointer like similar to how you would have declared or do some like using the new operation and everything. You can do the same thing with just the this operation. Okay, that's sort of the idea behind here. Okay, right here. Yeah. Okay, any questions? Okay. So yeah, if you guys have any questions, you can ask me, and we can start some topics in the next class about so we'll learn about inheritance. It's another very important concept of about classes, and what's the friend function. Okay, sort of the same idea about static, but for functions. Okay, that's a friend function, and inheritance is a very important concept. So we'll look at how parent and child functions get created, and how does this accessibility, I would rather say, for like you have private, public, and so on and so forth, right? So inheritance, how does it affect uh, uh, this kind of accessibility in different stages of your class? All right, so we can look at that in the next class. Yeah, in the meantime, if you guys have any questions, you can feel free to ask me. Sure. Yeah, another thing, The question is, can you cross-compile C++ code for Windows and from Linux? Ideally, yes. So the idea is that when you use codes like this, not just this one or anything actually, whatever we saw today, uh, we're using something called a standard. So that standard, as long as it's supported in both, not both, in any across operating systems, you should be able to use it. Yes. The other thing is, yes, there are some nuances one has to be careful of. Okay. The code itself, if it's not too complicated, as in it uses standard functions and everything. Let's say you're using standard template library, header files, sure. Uh, those header files have their own implementation in each OS, sort of. Okay. Like underlying what code it will call, as in what instructions it will call. Okay. That is sort of like wrapper. Your header file sort of acts like a wrapper for that. Your std outs, std endl sort of acts like wrapper for them. Okay. Because internally, what instructions will they call? Okay. That might depend on your CPUs actually. So that's actually the thing you can port across um, architectures where they support the same instructions, so the same architecture, but not across different architectures. So maybe you can't run the same compiled code for x64, okay, in ARM architecture, let's say. But across OSs, that should be fine. Yeah, because the header files themselves, you have to sort of, let's say, okay, this is another example. Let's say you have some custom named header file, okay, um, which includes some code or some object from some other file. So you have to now compile this guy, okay, this code, which is, let's say, object one, and link it with the object two. Okay. Now, let's say you port this object one to another OS. As long as you give the correct path, okay, while linking to the object two, again, that should also work. All right. Yeah, I hope that answers the question. Okay. Yeah, so the thing is, if you are trying to use external libraries, okay, in C++, in general, you have to link them. Okay. So there are ways you can give external libraries to linkers. You have to use flags like hyphen capital L and so on and so forth. But it makes your compilation like line, which at least is sorry, which at least for now is simple and looks something like this. But if you have more and more libraries trying to link, it becomes very complicated. So in those cases, people use some build tools. Okay. Uh, Very popular ones. Okay, Make used to be a very popular one and still is used, but it's a little old. You can use CMake. Okay, you can use Ninja with that. So there are certain build tools available. CMake is one of the most popular ones. So you take a look at that. Unfortunately, I don't think we'll cover that in this course at least. I'll be only covering the concepts, so I won't be teaching that. But I I think there is a tutorial you can look at that. Not entirely sure, but otherwise you can obviously okay, you can definitely find resources online how to use CMake tools and everything. That actually helps and enables you to build C++ codes for very large projects. Okay, so for external libraries and so on, you can, yes, fundamentally use just G++ command line, but it becomes you have to add more uh, lines here. Is what I'm saying. Yeah, you have to include path in your. You have to give the include directory for all your header files you're trying to link in your include path. You have to link with the external library using like the include path will be like hyphen capital I. LD, you have might have to add things to LD library path, the C path, so on and so forth. So Yeah. Yes, it sounds a little complicated, and how maybe some other languages do. But yeah, it's because C++ can be run on bare metal, like it gives you the close to metal performance and everything. So hence building also is very from the first principles in a way one can think of. Yeah. Okay, so used it for a commission. Okay, use CMake. I checked for CMake, but the library functions kept crashing with Windows.h functions. Oh yeah, so Windows.h definitely. Okay, wait. Are you running this in Windows? You're only using Windows, right? Was the cross compilation different question, right? Oh, okay. Yeah, then you can't use Windows.h, right? Because Windows.h itself will have Windows specific functions. You can't use them. You have to sort of give um, same functions that you're calling in C++, equivalent of that in Linux. It automatically imported Windows.h. Hmm. Okay, that should not happen. Maybe your G++ is for the Windows installation. Maybe check that. Because you normally, I mean, this is sort of not ideal to use Windows header files in Linux compilations, because then it will try to look for the. So actually, then what's the problem is the paths for Windows are not the same in Linux. And Linux, obviously, Linux paths are not the same in Windows. So both of them have two different ways in how they access directories. Okay, so yeah, things will not work in that case. So if you have to use Raylib libraries, and let's say you're in Linux, so you can give it a like have it in a custom path, okay, in some directory. That directory's full path, you can add it to your um, CMake or anything. And G++ or any GCC compiler wise, do check. I think better use uh, GCC or Clang, which for comes with Linux and everything. Yeah. Right, right, right. Yeah, ideally, I would not think, I mean, it is possible to compile and use with cross compilers. Yeah, exactly. G++ will perfectly be okay because it will include standard header files, which um, let's just say that those header files are sort of valid for across OSs. So that should work. The problem with uh, cross compilers, let's say like MingW is, I'm not specifically saying MingW problem, but when it tries to include very OS specific header files, then you will run into issues. Yeah. I don't know how the cross compiler works. I've not used that feature of MingW, but that's what my understanding will be. If it can avoid very OS specific includes, then you should be able to. Normally, mm, for as compilers, we at least we have been using mostly just GCC, and sometimes particularly we'll use Intel compilers, ICPX, ICCP, and so on and so forth. Um, Sometimes we'll use Clang or HIP as is the uh, compilation on AMD GPUs. So we use some Clang sort of compilers, but sort of the idea is that uh, at least my understanding will be maybe just stick to compilers that you install for that specific OS. Yes, cross compilation is definitely useful. But if you're trying to do it, maybe stick to compilers which are more supported. Yeah. Because if it tries to include OS specific header files, then yeah, that will you'll run into issues for sure. I have the files from last class and today's. Any other questions? Okay. All right. So last thing before we conclude. So yeah, again, learning concepts in C++ requires you to definitely practice. So write the code, compile it. The compiler will throw errors at you. Good, because it actually tells you where you made mistakes and everything. Okay. And we're trying to learn concepts like this. Uh, it's unlikely you'll run into some seg faults and such usually, but barring those errors, okay, when it's useful to understand from doing what do you actually what is the concept actually, so you learn better. Okay, so like we saw in this case, actually writing the code and changing stuff and just compiling and printing, you actually see what the output is, right? So that clears things more. So do practice, so you get your understanding better. Okay, right? Yeah. With that, we can conclude. I mean, if guys, have questions you can ask. Feel free to leave. Uh, yeah, I'll just be here for some time and then we can end the class. Yeah.
If there are no questions more, we'll end today's class. Yeah, like I said, to practice these concepts, and yeah, I'll see you in the next class. Happy coding.